polygons. And I know you've done this problem, but I'll just record it for other people too. Two figures are similar. They have the same shape but different sizes. The diagram drawn to scale to another diagram creates a similar figure. Likewise, an enlargement of a photo when reproduced to scale is a similar figure. For two figures to be similar, here's what we have to know. Angles, corresponding angles have to be the same, and they always will be. And the corresponding sides will be in the same proportion, meaning like 1 to 2 or something like that. Now, here's an example. If you draw a blueprint for a home, of course, your home will be long walls, but you're going to fit this on paper. So here, Tara's drawn a scale diagram of the bedroom so she can sketch different arrangements of furniture. On her diagram, the walls have all these lengths. Double tick marks means in inches, 3.4 inches, etc., 2 inches, etc. The longest wall in her real room is actually 12.75 feet. How long are the other walls? So the way that we're going to set this up is 12.75 feet for every, well, the longest wall on our diagram, we look quickly and I see that it's this one, A. So it's 8.5 inches. So that's 12.75 feet from here for every 8.75 inches. That's the conversion factor or the proportion that we're always going to use. Now, we're wondering about how long are the other walls? Well, let's just go with ABC, just go in order. How long would wall B be if it was in real life? Because here it's 6 inches, wall B. We could solve that proportion. Cross multiply, divide by the loner, so 6 times 12.75, divide by 8.75, or 8.5, my mistake here before we do any more work, 8.5. And we've got 9 feet. Now that's the same proportion you're going to use for all of them on the left-hand side. So that's the first wall. This one's 9 feet in real life. To do any of the other walls, you'd set it up the same way. 12.75 feet over 8.5 inches is equal to, well, what's wall C in real life? 6.5 inches here. You cross multiply and solve the same thing. You do the same thing then for D, E, and F. And do you have an answer for C already? 9.75. Great. Now, I'm going to leave D, E, and F for you to finish off. It's the same method. And when you do those, you should get 3.9 feet, 3 feet, and 5.1 feet, respectively, in that order. But let's just flip, because I think you got the idea now, right? Yeah. Example 2. We have 2 triangles. They're similar. That means their angles are the same. We don't know that, but this is not 80, this is 85. It's not a right angle. It almost looked like it at first glance, but it wasn't. Anyways. Angle L is 85. That's what those corners are like. Angle M, 78. Doesn't it look like that would be 78? So I'm going to label these right on here, and then it makes it way easier to do this. Angle L is 85 degrees. So angle R would also be 85 degrees. Angle M, there's 78. So this angle S equal to 78 degrees. Lastly, angle N, 17 degrees. So in the other diagram, angle T will be 17 degrees. Just because it's smaller, it doesn't change the angles. The sides are different, but the angles are the same. That's the whole thing there. That's a pretty simple one. But you need that to solve bigger problems. Now let's read one without a diagram. Jason wants to build a model of his house. He'll build the model using a scale where 5 centimeters on the diagram represents 2 meters in the real house. Okay. One room is 6.5 meters long, 4.8 meters wide, 2.8 meters tall. What will be the dimensions of his model? Well, we'll use units and everything and set this up here. 5 centimeters on the model, and that should be obvious because it's small centimeters, is 2 meters in the real life room, the actual room. That's going to be the ratio you use for everything for the model. Right? So, for the model, let's see here. One room is 6.5 meters long. Well, let's figure out how long in real life. I said this backward. No, I want the dimensions of the model, right? In the actual room, it's 6.5 meters, okay. L is the length on the model. We'd cross multiply 5 times 6.5 and divide by the 2. You get a length of 16.25 centimeters on the little model of the room. Likewise, how would you set it up for 4.8 meters wide?
5
Mm-hmm.
over 2 centimeters, and then W.
Sure, W for wide.
4.8.
Exactly. And then you'd solve that. And likewise, for the height of the room, the tall, I guess we'll use T. Same setup, 5 centimeters on the model, 2 meters in the actual room. It's just like T centimeters in the model, 2.8 meters in the room. And then you can solve those. You should get 12 and 7 for those. And when you do those, and then you're ready to try a few problems after that. Okay? I'll stop and see if the recording worked okay.